Here we are. So we finished the how to calculate Thevenin equivalent, Thevenin Norton equivalent circuits for a given circuit. Now we're going to see that how we are going to use these equivalent circuits in practice. So applications that we use, go in the details of that frame. We're going to use these Thevenin equivalent circuits in the circuit analysis, and we will also be using in circuit synthesis. So there is one frame for the analysis and another frame for the synthesis, and we will be having a video for the analysis and another video for the synthesis. For the analysis, let's see how we're going to use Thevenin equivalence in the circuit analysis. Now let me read it and then come to the how to use it. How could it be determined whether a circuit does the job properly? So let's say you have a circuit and it does a job. How do we know that it does the job properly, whether it works properly or not? That means answer is the put is to find out output elements, currents and voltages. Now consider that this is a equipment, your equipment, the whole of them, your equipment, and this is your output. So each circuit has an input and has an output. Your circuit, what it does means it transfers the input signal to the output signal. So the function of your circuit can be explained saying that this circuit transforms this input to that output. Output is an element current or voltage. So how I am going to say that this circuit job is to this circuit job is transfer the input signal to the expected output signals. Whether it works properly or not means calculation of the output in terms of the input. So the job it's doing is right means it transferring its input to the right output, then we say it is doing its job. To say that, we've got to calculate the output signal. So in this circuit now, the output is this element output. This element current and voltage could be the output signal of our circuit. So I've got to calculate this output signal in terms of course, independent source. Then I am going to say my circuit transfer this independent voltage source to this output, my expected output. If it is my expected output, that means my circuit working properly or functioning properly. If not, it's not functioning properly. So we could answer to that question by using the Thevenin equivalent circuit. How we have done it, here you are. This is the 5-element circuit that we have already examined, and we found the Thevenin equivalent circuit to this 5-element circuit, which is this. Now, this, if I put a load between the terminals A and B, which is that 100 k ohm here, so we are saying this original circuit, and I am going to find this current and voltage of this load. If I use the Thevenin equivalent circuit, I am going to replace all these elements with just 2 and put RL here. In this circuit, I can say that this element current is equal VTH over RTH plus RL. Not seen here, but I will correct it. What is the voltage? If you multiply this current with the RL, then you're going to get the voltage of the output element. So we said if we calculate this load element current and voltage, we can say that this circuit works properly or not. So it is just this formula that we are going to use to find the output signal. And you might say that, okay, it seems that that formula is a simple formula, But in order to find this Thevenin voltage and Thevenin resistance that we have done already, we analyzed two different circuits. So we paid something for the calculation of these values and to be able to use that formula. The advantage of this formula is this. So you could use this formula for any load that you connected to this. That means instead of 100K, you can use 25 ohm, or you can use 1 kilo ohm resistor, that you're going to use these formulas only. That means you are not going to find out the Thevenin equivalent. You found the Thevenin equivalent once, and for each load, you're using the same formula. But if you don't use the Thevenin equivalent analysis that we said here, for each load, you're going to analyze the circuit once more. So you're going to repeat the analysis for different loads if you're not going to use the Thevenin equivalent circuit analysis. That's why Thevenin equivalent usage in the analysis is important. Let me outline what we have done here. We are saying in the previous analysis, we have found out all the elements current and voltages. Now we are saying we are going to calculate only one of the elements current and voltage. So different analysis approach. Why we need that? Because we only want to check whether the circuit works properly or not. I want to find out the output signal only, not all the elements current and voltages. I explained already why we are calculating all the elements current and voltages. That's another reason for that. But now our aim is just to find out whether the circuit in front of us working properly or not. All we need is to find out one of the elements current and voltage. Then we are saying the Thevenin equivalent element is the best, because I will be using this equivalent circuit for all the different loads that I choose. That is why it is important. Thevenin-Norton equivalence analysis for cascade circuit. In here, our load is just one element, which is this resistor, but you could use the Thevenin equivalent circuit for two circuits connected in serial or in cascade. So one of the output of one circuit is the input of another circuit, which we call this is cascade connection. So this is circuit A and this is circuit B. Now we are saying we are going to analyze the whole circuit A and B together. The first, what we do, find out this green circuit, Thevenin equivalent circuit, which is this. So then we can analyze A and B together in here. So what is the difference? If you say that the elements, let me see it. The number of elements of A is M and number of elements of B is N. So if you do the analysis without using any Thevenin equivalent circuits, to analyze the whole circuit means you're going to analyze M plus N number of elements included circuit. But if you use the Thevenin equivalent circuit, this equivalent to this A is going to be just two elements and the number of elements in that common circuit in B. So N plus 2 elements included circuit will be analyzed if you use the Thevenin equivalent circuit, which is much less than the previous one. That's why it is important to use the Thevenin equivalent circuits. We need those because in electronics, one circuit output is the input of the another circuit. So this is common in electronics. So by replacing the first one with the Thevenin equivalent circuit would be beneficial for the analysis of the B circuits. Right, that is the end of the analysis usage of the Thevenin equivalent circuit, and then we will be examining in the next video we will be examining the synthesis usage of the equivalent Thevenin equivalence circuit. So that's the end of this video.